Ladies and gentlemen, distinguished guests, good afternoon. I am Chen, your moderator for today. Welcome to the forum of the AI Era, a collective effort toward AI systems pre-show forum. After seeing the teaser video of COMPUTEX 2026, I believe you are excited as I am. This year, the theme will be AI Together, and the exhibition will be on June 2nd to June 5th in the TWTC Hall 1, Nangang Exhibition Center Hall 1 and Hall 2 as well. And this forum, COMPUTEX this year, feature 1,500 exhibitors from around the world occupying 6,000 booths and showcasing innovations across 4 major domains: AI computing, robotics and smart mobility, next generation communications, and sustainable innovation. And so since COMPUTEX is ready, we now are seeing AI technologies accelerate their real-world adoption. Industry competition is shifting from isolated technological breakthroughs to system-level integration and large-scale development. And so through the forum today, the AI Era, a collective effort toward AI system, from the perspective of AI system, we will explore how cloud, on-premise, and edge environments work together and how platform providers integrate. And so before we get started, let's invite our distinguished guests. When you're called, please stand up and wave. Let's first welcome Taipei Computer Association TCA Chairman, Mr. Chen. Welcome, Mr. Chen.
Google Cloud APAC Vice President of Customer Engineering, Mr. Abdula.
MediaTek President and COO, Mr. Chen. Welcome.
McKinsey and Company Partner, Mr. Fletcher.
Hong Hai Research Institute CEO, Wei-Bin Lee. Welcome, Mr. Lee. E-Link Vice President of Business Center, Mr. J.M. Hong. Welcome, Mr. Hong. Acer Medical Chairman and CEO, Mr. Lien. Welcome, Mr. Lien. Also joining us today are representatives from foreign offices in Taiwan. When introduced, please kindly wave to the audience.
We are honored to have distinguished guests from Representative Office in Taiwan. Please kindly wave to our attendees as you are introduced. Please welcome Ms. Mathieu Boudoua, Blenders, Director of the Belgian Office Taipei. Mr. Janusz Henryk Bielski, Director of the Polish Office in Taipei. Mr. Jerome Burkenfen, Empire State Development, New York State Investment and Trade Office. Mr. Fernando Mariano Schmedo Hernandez, Director of the Chilean Trade Office. We are also honored to have many other representatives with us today. While we can't introduce everyone individually, we truly appreciate your presence and continued support for COMPUTEX.
Thank you very much for your support. And next, I would like you to invite to give a warm welcome and warm applause to Taipei Computer Association TCA Chairman, Mr. Chen, to come onto the stage for an opening remark. Ladies and gentlemen, distinguished speakers, industry leaders, and friends from the media, good afternoon. On behalf of the organization, it is my pleasure to welcome all of you to Taipei Computex 2026 pre-show forum. Today's forum not only marks the beginning of this year's Computex, but also serves as an important platform for us to collectively navigate the key directions shaping the AI-driven industry landscape. From AI PC and AI agents to cloud services, edge computing, and vertical applications, AI has become the driving force behind industrial transformation and competitive restructuring. This year's COMPUTEX features AI Together, reflecting the next phase of AI. a phase where the focus is no longer solely on models or computing power, but on system integration, real-world deployment, and ecosystem collaboration. In other words, AI is moving from the era of compute competition into the era of system value. This is the third consecutive year that we host a pre-show forum, which has now become a key platform for industry insights leading up to COMPUTEX. Under the theme, The AI Era, a collective effort toward AI systems, we have invited global technology leaders, expert consultants, and representatives from Taiwan's industry to explore how AI systems can be truly implemented at scale. Today's 6 sessions highlight 6 essential dimensions of AI adoption. First, we are happy to have Mr. Mo Abdula, APAC Vice President of Customer Engineering at Google Cloud, who will share Google Cloud's practical strategies for the AI systems era, showing us how enterprises can leverage cloud, data, and AI capabilities to accelerate real-world deployment. Next, my old friend Mr. Chen, President and COO of MediaTek, will discuss how smart devices and edge AI extend cloud capabilities to every endpoint. Mr. Fletcher, partner at McKinsey and Company, will then examine how AI can scale through the lens of critical infrastructure, including power, cooling, networking, and compute. In the area of AI governance and trustworthy AI, we are honored to have Dr. Wei-Bin, CEO of the Hon Hai Research Institute, who will explore how AI can be used safely and trusted by enterprises. From the perspective of e-paper and smart retail, Mr. J.M. Hong, Vice President of E-Link, will share how AI is entering everyday commercial scenarios. And finally, our fellow Acer colleague of mine, Dr. Lien, Chairman and CEO of Acer Medical, will offer insights into the challenges and opportunities of applying AI in the healthcare sector. These perspectives reflect the core message of today's forum. AI's next chapter is not about showcasing technology. It's about industry-level implementation. It's not about isolated innovation, but about system capabilities and ecosystem collaboration. This year, COMPUTEX reaches a new milestone, bringing together more than 1,500 exhibitors and 6,000 booths, showcasing the full spectrum of AI innovation from chips and platforms to system integration and real-world applications. Taiwan is rapidly becoming a key global partner for AI system deployment. We also hope COMPUTEX will continue to serve not only as an exhibition platform, but also an catalyst for international collaboration and business opportunities. This year, we are extending the COMPUTEX experience beyond the exhibition halls and into the city. On the evening of June 2nd, a spectacular MIT drone performance will take place around Taipei 101, combining technology, art, and the city skyline, and will be live-streamed globally to showcase Taiwan's innovation energy. On June 3rd, the Innovex Night Party will also be held at Taipei 101, bringing together international startups, investors, and industry partners, making Taipei a vibrant hub for global innovation exchange. In closing, I wish today's forum a great success, and I hope each of you will gain valuable insights. Thank you very much. Thank you. Let's thank Chairman Chen. Thank you so much. Please stay on the stage. As Chairman Chen mentioned, AI is now moving into system integration at scale. So combining the ecosystem is very valuable. It is the next milestone. Chairman Chen also mentioned the 6 sessions today. So I believe we are all excited about these sessions. So let's take this valuable opportunity and invite our guests to come onto the stage for a group photo.
Would now like to invite our VIPs to join us on stage for a group photo. Please welcome Google Cloud APAC Vice President of Customer Engineering, Mo Abdula. McKinsey and Company partner, Fletcher.
Hon Hai Research Institute CEO Wei-Bin, Mr. Lee. E-Link Vice President of Business Center, Mr. J.M. Hong. Acer Medical Chairman and CEO, Mr. Lien. Please come onto the stage for a group photo. Please look at the camera in the front and smile.
Please look toward the center camera and give us your biggest smiles.
Thank you so much. Now, please kindly return to your seat. Thank you so much.
Next up, we would like to welcome Mr. Chen from MediaTek. And his topic will be AI Everywhere, Era of Agentic AI from Edge to Cloud. Ladies and gentlemen, good afternoon. I'm really happy to be here today to share with you this topic, AI Everywhere. I think you all know that MediaTek is a tech company. We are also a product-oriented company. Every year we manufactured many products that can be applied to many devices. For example, your cell phones, your TVs, your tablets, and your IVI products may have come from our chips. And you all know that MediaTek has now ventured into data centers operating chips services. So from cloud to the devices, MediaTek has spanned a lot of services. So we are very willing to share with you our first-hand experiences in our observations, and we would like to share with you how AI is evolving and how it's going to change the lifestyle of the consumers, especially those in the midstream. Since 2026, at the start of 2026, we're seeing a lot of investment in AI. So there are three things I would like to share with you. The first is the capex of AI now reaches $700 billion. This is astonishing. It's even larger than some countries' GDPs. So this is actually a really amazing infrastructure, because that will allow us to have more computing power on AI. And with that, the services can be driven. And now AI is rapidly evolving from procession AI to directive AI to generative AI. And actually, we are seeing a lot of chatbots and a lot of AI chats. And with that, we are able to gain a lot of real-time information for inference and analysis. Our last speaker mentioned that we're going to have a lot of agentic AI everywhere. So what sets agentic AI apart from traditional AI is that it has the capability of reasoning and judgment. Agentic AIs can also take actions for you. With that, AI will be able to help serve our customers in so many possible ways. Of course, going forward, you will see rapid development of AI. That is, of course, for sure. And the third thing I would like to share with you is OpenClaw. It's actually an open source. So it's actually very popular. Every month, it has been downloaded many times, and there are many active users. So you can see that this is actually a core in the open source ecosystem, and we believe that this will help agentic AI to boom this year. So what does this mean to all of our consumers here? Well, with the era of agentic AI, the form of our products will be changed and the user experiences will be transformed. So we're going to call this agentic AI devices. For example, your cell phones is now called smartphones. Maybe in the future it will be called agentic AI smartphones. And the experiences coming from all of this will also be transformed. of course, the smartphones will allow you to download and to install all the apps. With the GUI, you are able to execute anything that you want. But with agentic AI, all of these experiences will be more proactive, real-time, and customized. So we call this agentic AI user experiences. Agentic AI user experiences. So in the future, we imagined that with so many agents, the product, of course, will change. The experiences, of course, will change. I'm going to show you a video. I hope that this will allow you to see what is like to have agentic AI and the agentic AI user experiences. This video now features a lot of the user experiences for the agentic AI. So is that wonderful? So this is what I was talking about, agentic AI user experience. So to summarize, the agentic AI user experiences have 5 features. The first, of course, is that it will be more proactive and real-time. Like I said, in the past, the user experiences actually means that you have to enable the services that you want. But in the future, AI will know what you want or the possible services that you want. So it will proactively call out all of these services that you might need. So this is what we call proactive and real time. The second thing is that it will understand you more personally. Since it has the short-term and long-term memory, this services will understand your preferences. When it is trying to serve you, it will be more customized. Now, the third thing is interactive collaboration. In the future, you can imagine agentic AI devices will be everywhere. So they will be able to communicate with each other. And with that, your services will be enabled by multiple devices. That is what we call by interactive collaboration. Now, the fourth thing is continuous learning and evolution. The more you use, the more it understands you. So it will continue to evolve. Now, last but not least, privacy is, of course, a key issue here. Now, the AI will, of course, store your information on maybe the cloud or a secured device to help protect your privacy. Now, this might sound a bit ambiguous, so I'm going to give you an example here. So let's take travel and driving and working as 3 examples here. So the first thing I would like to start with is the agentic travel experience. Of course, I would like to show you a video here. This is a good example. When you travel to a new place, you can use your AI glasses and your AI phone to interact with each other. Of course, there's camera on your AI glasses that allows you to interact with the world in the real time. So what you see through the glasses will be transmitted to your phone, and it will be identified and recognized in a real-time fashion. And as a tourist, you will be able to receive recommendations and information with that. Now, the second experience I would like to give you is driving. So just imagine you have a kid and you have to pick him up. So when the kid is in your car, the kid's phone will, of course, have an AI, agentic AI. So it will communicate with the agentic AI in your car. So that will send a message to the car that it knows that you have picked up your kid and they will arrange for the trip home. And of course, your phone will have a daily life agent. So of course, this AI will keep track of everything. For example, you will have dry cleaning a week ago, and the laundry shop sends a message to you that this will be done in a week. Usually, you will forget about this laundry because you have too many things to keep track of. But with this AI, they will notify you when it's done. So with that, this will be kept inside this AI's memory. Now, this daily life agentic AI knows that your laundry is done, your dry clean is done, and it is actually not far from the school of your kid. So it will communicate with the vehicles and says that you should stop by the laundry shop, and then you will be able to be back home by 7 o'clock. So this will send a proactive alert to you so that you will know you need to pick up your dry clean. So the agents are communicating with each other, and this will create a new driving experience. That's my second example.
My third example is about work. The previous 2 examples come from your daily life, but agent, of course, will not only reshape your life, but also your experience at work. Imagine this. In the past, when you process an email, you may have hundreds of emails, you review them one by one. Some of the emails may involve decisions, and in your decision making, you may need more information to make that decision. So you may need to go collect a lot of other information to answer that email. So imagine you have a work agent who can review the emails with you. And when you realize that this particular email is just sharing for information, and the agent understands that how I would share this particular information to where, or this particular email is about a decision making, but some information is required, and the agent will automatically find the information for you and give you information A, B, and C because it identifies these three are what you need. And you can interact with your agent and discuss with it about how to make this particular decision. So this agent will reshape your work environment as well. So imagine in the future, agentic user experience does not just happen in your daily life, but also in your daily work. And the most ideal demonstration would be that all these experiences would be seamless because the agents would talk to each other. It would be completely intuitive. Just like other experiences, it will be so easy to pick up and so easy to enjoy. Another example in our current life, in our products and ecosystem, you may experience inconsistency between the product and the experience. So as a consumer, when you want to switch an ecosystem, it may be very difficult. For example, an experience of my own. Usually, I work on Windows-based systems, and previously I bought a Mac OS computer, and they're both computers, but the OS are different, the ecosystems are different. Simply closing a window of a program will be different. For Mac, you need to look on the left-hand side. For Windows, you will have to. For Windows program, you need to go to the right-hand side to close this particular window. So I have to ask my son how to turn off a program or a window on Mac OS. But in the future, it'll be so easy. Just tell your agent to do that. So the agent user experience will be consistent across your life, and it will be the same and consistent across different ecosystems and different scenarios in your life. It would even be universal and cross ecosystem, and the agents will be able to talk to each other. So that will be the ideal agentic AI user experience in the future. In your daily lives, in your work, agents, we believe, will bring such a big difference. Talking about the differences, MediaTek, of course, is a product technology company. We are getting ready. We are ready to provide you and to enable such wonderful changes. I would like to show you our contribution in 4 areas, from the edge layer, system layer, application layer, and infrastructure layer for AI. Let's begin with the edge layer. These 4 layers comes with their individual challenges and opportunities. For the edge layer, the biggest challenges, of course, is compute and power. On the edge side, we need bigger batteries or better batteries. For small glasses, you can only use a battery 1/10 the size of your phone. Usually, your smartphone battery should ideally last you for a day. So for device edge compute, it's really important to strike a balance between compute and power consumption. As you know, in many scenarios, you can use cloud computing power, but for some scenarios, you need edge compute. So because there could be latency or connectivity issues, so edge compute is really critical. Another issue with edge compute relates to another layer. Because in the future, the service at the endpoint will move from passive to active. Like the passive experience in the system layer will be like the left-hand side. If you need 3 services, you may call 3 apps. And the apps will call your platform and operating system to enable the compute required for these 3 apps. And in the future, the compute will not come from the apps, but from the platform, because the platform in the future could be able to sense actively. As I mentioned, many experiences will be active, so the platform itself would need a very strong local OS compute power, an upgradable power. And these capabilities would enable agentic OS, and the OS would know the action to be taken. And in the process, the OS would very easily allocate the required compute and enable the required actions and skills. So for the system layer, the challenge is not only comes from the OS but also the hardware. Even when these two layers are ready, it's not enough. MediaTek offers a technology platform, and the platform needs to allow all the service providers, developers to realize their products in the platform. So this revolves issues on the ecosystem, the application layer. So you need very good developer kit so that developers can deploy on cloud or on edge. And we also need very good developer toolkits so that our partners will be easily develop services on our platform. Talking about the services, the final ecosystem, from our perspective, will be an agentic ecosystem. In this agentic ecosystem, you may see part of the old ecosystem being transformed into this new agentic ecosystem, or completely new agentic ecosystem developed that can coexist with the original old ecosystem. Whichever way, in this future agentic ecosystem, it must create value for the user. So that depends on the service you can provide. That depends on how many partners you can attract to the platform to scale up, like Google's GMS or the Google Play App Store. There could be hundreds of thousands of apps on it. So that definitely is a good ecosystem. And how such an ecosystem can deliver true agentic ecosystem to end users is the key. If the end user find this valuable, they'll be willing to pay for the services, to buy these token-based services. So in the future, this ecosystem is not about buying apps. You're buying tokens for the services. The tokens may come from a certain software or a model provider for certain new features. And the tokens may be used to work with agents or things like open cloud. So MTK, MediaTek, is not only about preparing the technology platform, but enlarging, scaling up the ecosystem as well. As I mentioned, I talked about the endpoint on the edge, but on the cloud side, there are a lot of challenges and opportunities as well. For example, the per watt performance and the cloud compute demand is stronger by the day. So many different technologies in processing, on packaging, from 2.5D to 3.5D packaging, or the interconnecting technology from 200G, 400G to CPO. These are technologies that are happening and will be realized soon in the future. So finally, I would like to conclude with this slide. You can imagine tomorrow's world will be a mix of cloud and edge. On cloud, there will be enough available compute with dozens of gigawatts, and the compute will be used to train LLMs or to do reasoning for LLM. When your LLM is super big, for example, hundreds of billions of data, of course, we have to run on cloud. And on the edge side, on the endpoint side, of course, there will be many agentic devices. They're very important as well, because these devices are the touch point or the access point of end users, of consumers. So without agentic AI devices, consumers won't be able to access the cloud compute. So with the devices, they have access to cloud compute, and the cloud providers will be able to profit and reinvest in their infrastructure. So it will become a virtuous cycle. So I believe in the near couple of years into the future, the development of the ecosystem does not rely only on cloud and infrastructure, but also on the billions of agentic AI devices. As you can see, in some scenarios, you need to rely on cloud compute. In some scenarios, you need on-device or edge compute. In some scenarios, it will be a mix. By mix, I mean good communication between edge and cloud. So I often joke that in the future, there will be tokens flying around on the cloud. It will be computed, the compute will happen on the cloud and it will be sent to the edge, so the tokens will be flying around all over the world. So in the future, I see token-based traffic and coordinated operation between cloud and edge, and better communication between the two. In a world like that, it will present big opportunities for silicon and semiconductors. And I believe on MediaTek, we invest on technologies on the cloud side, on the edge side, and it will allow MediaTek to become a very important innovator and driver for innovation. And I am very happy to share this vision with you.
Thank you, Mr. Chen, for your wonderful presentation. So in your presentation, you talked about agentic AI. It serves sort of like a project manager because it coordinates different AI agents, and it actually helps different tasks to be connected and through customization and a lot of other applications. And it can be very helpful in many ways. For example, traveling or in our daily life, all of these can be recommended through the AI. For example, I saw that video, and I am very, very impressed by how our AI technology will evolve. I really do believe that this will help a lot of people's marriage, because you actually do not have to do the laundry anymore, and you don't have to be yelled at because you forgot a certain errand that you need to run. And with that, of course, you will have happy marriage and happy wife, right? Now, I would like to move on to our next speaker.
Good afternoon, everyone. It's great to be with you guys in Taipei. It's especially great to be here with you guys at COMPUTEX. Let me just start out with one premise. AI, when we talk about AI, it comes across as this weightless thing. It's this amorphous thing that's talking about tokens and algorithms and memory and compute and intelligence and reasoning. But I argue that AI actually has real weight, and I think most of us in this room know this. AI has physicality. It has a real address. It has chips and memory and copper traces and cables and wiring and cooling loops and chillers and racks and infrastructure and power distribution and substations, all of which sit at the very core of what enables AI to function. My name is Ryan Fletcher. I spend most of my time with many of the industrial and electronics companies worldwide that form this backbone of AI. And as Chairman Chen had mentioned earlier, this is a real key element that I believe is going to dictate the pace at which we move in the coming decade. And I would posit that AI progress is no longer going to be from model to model, but instead from infrastructure to infrastructure and from system to system. And so on that premise, when we think about AI, we're really moving in an era from prototype to production. And all of us who have been in a manufacturing environment before know that a prototype is very good at hiding all the problems with a system that come out when you actually get it onto the factory floor. And we're in a very similar vein. The theme of this session is about AI's capability and AI's infrastructure. Now, the new four horsemen of AI scale, I have to say that starting a technical talk by talking about the apocalypse is an interesting choice. But bear with me. In the old story, those who'd be familiar with it, the four horsemen warn of challenge and warn of great system stress. They don't all arrive at the same time. They actually come one by one, but each one builds upon each other and amplifies the magnitude of the problem until you have a system that really can no longer function. And so, when we talk about AI infrastructure, we talk about power, cooling, networking, compute. This sits at the very brick and mortar heart of AI today, and each one influences the other. And so we would say that AI's ability to scale is no longer constrained by any one of these systems. It's constrained by the ability of these four to work together consistently. So let's just take a quick look through them. We don't have a lot of time. There's a lot of depth that we could go into, but we'll just graze over a few of the points I think are important for us all to recognize about how all the AI capabilities we talk about today in a COMPUTEX really sit in the physical world. So starting with power. Now, one interesting thing about power, if we think about the use of power for AI is power used for intelligence. What other model do we have for power being used for intelligence? Well, we have the human body. That's really the only other model we ever have. And if we think about power as in calories and food intake, the food and the beverages that we consume, and the calories of energy that really creates, we find that the human body uses about 22% of all of the power intake to power the brain. Right? Now, some people higher or lower than others, but on average, it's about 22%. Now, you look at other species that we consider to have good intelligence, crows, dogs, pigeons, all much less than the human brain. And so far, until AI, the human brain has been the hallmark of intelligence capability. So let's think about power now for the artificial intelligence side of this. Let's just take the US. In 2025, the power demand used by AI in the data center world has already reached 4% of all of the generating capacity in North America. By 2030, that's going to rise to 14%. Now, that rapid rise of 14% is coupled by another problem. Only 40% of that incremental capacity by 2030 is planned today for supply. Why do we know that that's all that's planned? Well, it takes years to onboard new power generating capacity, let alone the transmitting ability of that. And all of those projects are basically planned today. And so in North America, we have an extreme power crunch that's going to dictate the pace at which we can scale. Now, let me give you a practical example of what this means. There's a company that I'm familiar with that was working last year to plan out their next data center expansion in Texas. They had everything laid out pretty smoothly. They had their site selected, they had their building spec'd out, they had their EPC and their general contractor ready to go. They had all the infrastructure ordered, they had the racks, the cables, the servers, the solutions, all of the hardware that they would need. And it was a pretty simple layout, right? There are 3 phases. The first phase was to get some initial compute on board. Second phase was to scale that compute a bit. And then the third was to really expand it into a bigger data center campus. And this whole plan was very well laid out. And then they had the meeting with the power company. And for any of you who have met with a regulated utility before, you'll find that they move at a very, very different pace than the rest of the industry. And so this was a very awakening moment. The power utility didn't say it was not possible. They said, look, the first phase, it's totally fine. The site was scoped to have this amount of power capability. We'll make a few changes and you'll be good. Second phase, gosh, you want to do that in 2 years? That's new work that we have to do on the substation. That's at least a 3-year project. And third, a full data center campus, gosh, that's generating capacity and transmitting capacity that we don't have. We're talking a 5-year journey, right? And so we're in a world in which power is really becoming the calendar of AI for us today. So let's talk about cooling for a moment. Now, cooling, when you look at on the surface, the cooling requirements for data centers don't seem to be quite as stark. But look at the baseline that we're comparing to. Baseline of all the cooling capacity in the world is all of the ventilating and air conditioning in residences and homes worldwide, in addition to all of the refrigeration capability, commercial and residential, right? That is and you think of all the square footage that we are cooling with that capacity, and that is a massive environment. And so when we're at a forecast of 13% of that total within 10 years, that is a huge amount of cooling. Now, there's two things that make this cooling very different than any other type of cooling that we've dealt with in the physical world. One is that it's on 24/7. So unlike air conditioning, where it's subject to the external temperatures, subject to the climate that's going on, the season, and the time of day, this, for data centers, is on 24/7. The second challenge is that it is highly concentrated. We might use an enormous amount of, what we think is an enormous amount of air conditioning to cool this room off from the hot weather outside. But when you think of a data center, we are concentrating that cooling on incredibly small points. And that is one of the biggest challenges to get right. And so as we go in technology, evolving from air cooling into liquid cooling, and then within liquid from in-rack cooling into direct-to-chip cooling, we have a roadmap in which we have to be able to get this right. And the cooling world, is something that has a lot of tech evolution around it. But one thing we often miss, and every time I'm talking to a cooling company in the data center world, is they're missing the picture of how does this scale. I'll give you another example. There's a manufacturer of racks in North America. They developed, about a year and a half ago, a pretty novel cooling capability for their rack. This was considered an exotic approach, but it was highly effective. They had the rack built, but then the challenge came for scale. How do they service and support that rack? How do they build it out so that longer term it can be maintained over time? How do they figure out the technology so that they find the failure points, they fix them and prevent them from causing issues within the data center environment? And so in many ways, when I was speaking to the CEO of this company, he explained it to me as, we want to have really great technology, but we want to make it completely boring. We don't want anyone to have to think about the cooling capability in their data center. It has to just work. Coming up with the idea and the innovation is 10% of the problem. 90% of the problem is how do we scale it and we service it and support it. So let's talk about networking. Now, networking is an interesting one. When you look over the basically the past 20 years of compute architecture and networking bandwidth, you see a huge divergence, right? When we take a proxy of compute capability, which is hardware flops, and we say over the past 20 years, we have had 60,000 times the advancement in hardware capability on a flops basis. Our interconnect, our data backbone interconnect bandwidth over that same time has increased 30%. This is a massive delta. Now, yes, you can solve it by having more interconnects, right? That's what we've done, is we've thrown hardware at the problem. But what this creates is a very interesting yield situation, and those of you in manufacturing will understand this very, very intimately. We call this hitting the network wall, and there's substantial cost when this happens. Take a large data center. We found that the GPUs in that data center run idle anywhere from 30 to 60% of the time. This is not large idle time because there isn't demand on the chips. These are small amounts of idle time in between runs because they're waiting to get data in or out. So when we're talking about all of the investment in AI capability, but yet we have all this latent capacity, what does that mean? Well, it means almost $500 million of extra energy spend, over 180 kilotons of extra CO2 emissions. If you're developing a next model or advancing your inference capabilities, it could be weeks of delay to launch that model. And then what a lot of folks don't recognize is that there's a real opportunity cost of the inference you could be running and you could be charging your customers for, right? And so when you put this together, many times we hear in the industry, hey, we can't get as much out. We do have some idle time, but that's just latent capacity, right? That's just latent capital that we've invested. But instead, we like to say that that's not just latent capital, that's capital that's quietly leaking value over and over again. Now, there are a lot of solutions coming out to address this gap, right, and to really accelerate things. We're moving from discrete pluggable physical transceivers into AI era pluggables, XPO, and then eventually CPO. But the challenge with this, of course, is how do you service and support it? What's holding us back from doing co-packaged optics is that service and support question. When something goes wrong, how do you replace it when it's built into the chip, right? What do you have to do? These are the real fundamental infrastructure questions that need to be solved for us to be able to close that gap. Now, the last horseman is the one actually that everyone tends to see first, which is compute. We all tend to think about designing our systems around the compute capacity, but we see it first typically for the wrong reasons. Compute performance we see as setting the pace, but instead, we should think about compute as driving the choices that we make in the infrastructure in which we install. So what do I mean by that? Well, different goals require very different system approaches. Right now, we're installing data centers and data center capacity. What we really need is to figure out what do we actually want from a system standpoint. Are we trying to get better tokens? Are we trying to solve problems no one has ever solved before? Are we trying to perform a task much better than anyone else, right? Then that means we need to optimize our infrastructure for better tokens. So that's going to be frontier systems, high rack power, some of the most advanced cooling and networking capabilities that we can get. But are we trying to do, on the flip side, cheaper tokens? We're trying to repeat something that we've done over and over again and just do it faster and better. Well, then we need to optimize our infrastructure for efficiency, right? It's our scale-out networks, it's our throughput, it's our cost discipline. And the comparison here I like to make is that on the better tokens, it's like having a Formula One garage. You have your race car, you're making tweaks to it here and there to allow it to run faster around the track. You really don't care much about cost. It's all about the speed that you can get so that you can win the race. The flip side, cheaper tokens, it's like having a world-class, highly efficient manufacturing facility where the bottlenecks are minimized, things are running streamlined, failures are addressed right away, right? And it's all about optimizing that efficiency and that yield. And so, while we tend to think of installed compute as a purchase order, productive compute, what we ultimately want is a system and design decision. So there's a lot more that we could go into on each of these, but I'm just going to leave you with a handful of thoughts. On power is the calendar. It's setting the pace of AI today, right? That may change as we get better technology, better inference, but at least for the next 5 to 10 years, this is one of the biggest constraints we have in building out infrastructure. Cooling sets the adoption curve, right? Our ability to really extract the heat efficiently and effectively and repeatably in a way that you can service and support in an infrastructure is going to be critical. Networking is about utilization layer. How do you increase utilization of the inbuilt systems you already have? And by the way, I was speaking, one point I had on that slide was that I was speaking with a transceiver manufacturer a few weeks ago, and we'd done the math and seen that if they could only reduce that idle time by 25%, they could charge $4,000 more per transceiver, which the answer was, well, we don't think we're charging enough for our product today. And compute, it's really a systems decision. It's not, it shouldn't be the thing that gets kind of decided at the end. It's a thing that architects with the way the system works. And all of these constraints are incredibly coupled. Compute density changes in that, changes the need for cooling. Changes in cooling change the facility and the rack design. The rack design impacts the power availability and the compute utilization, which in turn impacts the network architecture, and then of course how you select the site, right? And so these constraints are incredibly closely coupled. Those of you who are familiar with the semiconductor manufacturing environment, think of a semi-fab. The most efficient semi-fabs we have minimize bottlenecks. They don't just look at one golden tool, right? They're not optimizing one thing. They're working across the system to minimize bottlenecks, to ensure that the litho and the dep and the etch and the even things like the clean room hygiene and your technician availability and so forth are all working to optimize the end system. right? You're trying to avoid having one thing holding up the rest of the infrastructure. And that's really where we are with AI infrastructure today. I'd like to say that a few of the mindsets that we think are going to be critical. One is physics is value, whether it's cooling or optical data transmission, solving the physical problems has massive, massive tangible value today. Designed for the bottleneck to move, right? It may be in one deployment, cooling may be your rate limiting factor, and another one it's networking, right? But you have to design for that. Treating utilization as yield. It's real cost. It's not just capacity that's latent, it's real cost to the system. Closer integration across domains. We have to get closer. We're getting to a world in which power and cooling and networking and compute all are starting to converge. Not only at the rack level today, but at the system level and eventually at the chip level. And we need at least 2 AI factories because we're going to need 2 different types of jobs, right? The Formula One race car and the factory. And that might even increase in the future, but today it's not a one-size-fits-all model. So, the look at the 4 horsemen, right, is not necessarily supposed to be an impending element of doom. The idea is that it's a harbinger for avoiding fragmentation, right? Getting power, cooling, networking, and compute all to work together collaboratively so that this doesn't only become infrastructure. This really is able to set and define our AI strategy. So thank you very much.
Thank you, Mr. Fletcher, for the insightful presentation. Thank you.
Thank you, Mr. Fletcher, for your wonderful presentation. So when it comes to AI scaling, he mentioned the apocalypse metaphor, but I do think that when it comes to infrastructure of AI scalability, there's these 4 issues that we need to keep up with. So these are the things that we need to look out for. So next up, we would like to welcome our next speaker, Mr. Lee from Hon Hai Technology Group. Please. So what he's going to share with us is the enterprise AI and AI security. Good afternoon. So I was assigned this topic by the organizer. I think that this is actually a timely topic. I've been in this field for quite some time, so maybe I could weigh in a little bit. That is why I did not change it. Well, you see in my slides, there's the notebook LM. Well, I have to say that because I don't know how to really create slides, that is why I just send out all of my notes to the notebook LM, and there's the pictures and images coming out. So I originally wanted to talk about agents and non-human. I just did not know, and I just did not understand why it would create something that I did not want. So I left it out. That is why you see some of the slides are marked by notebook LM. But basically, all of this is coming from my personal notes, and it actually helped boost my productivity. So I would like you to bear with me. I know that some of the words might be a little bit weird because it doesn't really look like the real characters. It is created by AI, therefore you would see that it is deformed. But with that, I would like to tell you that AI is not perfect, it's imperfect. So now we are seeing the era of AI, but it has not benefited everyone. If you want to talk about AI inclusion or AI or AI security, well, security by design is very important, but we do not have that, and we also do not have the AI by default. So there's a lot of problems coming from this. So in addition to cybersecurity, I think that AI can also be exploited by hackers, and AI itself also generates a lot of problems. For example, a lot of the attacks and posing data and proper prompt injection, all of these were never issues in the past. But now with the AI era, these issues are something that we need to bear in mind now. So with this picture, with this slide, I would like to tell you that this is something that we cannot avoid. I think that some of you have already seen some benefits coming from this, and a lot of the executives would like to invest in AI. So I don't think that any enterprise would run away from this trend. But with that, what about the employees? What about your staff? So this is actually coming from Stanford's HAS, the Human Agency Scale. So there are 5 levels. The first is, of course, the no human involvement, and then all the way to human involvement is indispensable. So you see the AI-led with human oversight or equal partnership, and human-led with AI assistance. So in this different phases, what are we looking for? I think that most employees are looking for an equal partnership. So with that, when we talk about the automation, what exactly is the ideal fit for us? So I think that this is the scale that we need to really bear in mind. Now, this is another issue here. So we see a lot of AI capabilities, and we want to know whether or not AI really could live up to that. We don't know that yet. And is there any expectation of AI's capabilities? Well, there are 4 quadrants here. So if you have good capability with low desire, this actually is a red flag zone. That means you will face a lot of opposition coming from the employee. So they will be a little passive towards this development. That's the employees. They are not against your development, but they are taking it really, really slow. Of course, that is not good. Now, if we have the capabilities there, there's a lot of hypes of AI development, and we know the maturity of AI development. So, of course, the half cycle that we talked about, you could have POC, and you probably do not have POC, and there's also employees' desire. Then, so you have the red light zone or the red flag zone, and you also have the green light zone. So what about the upper left? So that means with upper left, that means everybody's looking forward to that, but the capability is not there yet. So I've been with Foxconn for many years. So what are the models that we could employ to perfect the AI capabilities? Now, with the bottom left, this is the prohibited zone. You don't want to be there. You do not have the desire, and you do not have the capabilities. Of course, you do not want to venture into that quadrant. So if you are facing obstacles of AI development, that may not be your problem, but it could be the problem of you finding the wrong applications. Now, another issue here is that many of the capitals have been flown into the wrong quadrant. 41% of the capitals are in the wrong quadrant. For example, in the VC here in Taiwan would like to invest in some more mature technologies, but for the YC startups there in other countries, they probably would invest in the red light zone and the low priority zone. Now, when we first encounter generative AI, it actually caused a lot of problems, but now we are seeing a lot of agentic AI. Agentic AI caused another set of problems because it could take action on its own. In the past, all of these actions were taken by human beings. So the human beings are actually a buffer. You could actually weigh in and to hold certain actions. But in the previous presentations, you saw this video where a lot of the actions have been taken by the AI. The tickets were ordered, and the agents have already arranged the schedule for you. Now, that comes a problem. What if it is a wrong decision? So you have to have a boundary here, and you have to have a proportionality principle. We have seen a lot of user example. You want the AI agent to delete an email, but it failed to do that. So basically, what it did was to find your loopholes, and then the AI agent went into your mail server and killed down or to kill the mail server to delete that certain email. But you could see that this is actually not right because you are actually wasting a lot of your resources. So you are asking AI to do one thing, but they're trying to do a lot more things to achieve that goal. That is something that we are frightened of. In the past, currently we have generative AI. There's the hallucinations. Hallucinations are actually fine because you have human judgment to help you. If you have a lot of hallucinations, you probably do not have to worry about that. But now many young people simply just take in what AI feeds them, even if it is hallucinations, and they are not able to tell whether or not they are hallucinations. For people of our generations, we are able to tell whether or not these are right or wrong. But now you're seeing a lot of the novice or the newbies. They don't know how to decipher the message. That's another issue, Now, this is another thing I would like to address. Technology adoption is inevitable. Like water flowing downhill, it flows the path of least resistance. For example, when laptop first came into being, people would like to use their own device, and then there came the cell phones. When we were in the universities, when we were in college, there was no such thing as desktop PC. There's no personal computer. There's only the mega computing machine. So people before me had to use other mega devices. But then we're seeing cell phones, and now we're seeing shadow AI. The employees did not like the software or the applications of the company, so they are bringing their own applications. Now, there's the problem here, because it is not a top-down approach, because it is not authorized by the executives. It is actually done by the employees at the bottom. And now we are trying to tell people that you need to undergo digital transformation. You need to use a lot of software and other things. But now, these employees are now using their own software. And what they're trying to do is that they are using their own preferred services. So that's the problem with shadow AI. And now we are seeing the potential problem of shadow agents. So when you are trying to develop AI capabilities, all of these things would come to you. If you stick to the old mindset, you are not able to keep up. So how do we keep up with the problem of shadow agents? I think that the speaker from Google Cloud actually mentioned a lot about this. So agents are non-human employee. So we need to, of course, educate it. Maybe in the future, what we call human resources may have to be agent resources. So the engineers will have to run a lot of agents. They will probably become the future human resources department, right? So when you have new employees, when they are on board, you need to set up their you need to set up their authentications, and also you need to authorize them into a certain security level. So you need to set the clearance. But in the future, you will also have to do that for the agents. Now, another thing that we need to be aware of is the non-traditional attacks. For example, the natural language attacks. For example, the hackers might create a software. It is actually an agent that will go to AI for help. For example, it goes into your system and it asks your AI to create the attacking behavior. So it looks like this person is innocent, but it is exploiting your AI. For example, it asks the hacker asks your AI to delete an email or to delete a server. So there's the coding pattern or behavior, and your AI is there already. It is in place. So when you introduced AI into your system, of course, you need to think about security, your cybersecurity. It's not just about accuracy or precision, because it could become a place where the hackers could exploit. Now, a lot of the solutions nowadays come with AI. A lot of vendors say that they have AIs with their solutions. So with that, you have to know that they need to train their AI. They need to collect their data. So what about these black boxes? Where do these come from? For example, we know that you don't ask a lady how old is she. So what about AI? You can ask AI you can maybe set a certain question set that you cannot ask AI a certain questions. So these are the things that we never thought about in the future, right? And now we also have the gaslighting and social engineering problem. We want AI to align with us. It has to meet our demand. And with that, you can see that it's actually trying to please you. The more you train your AI, the more your AI would like to please you. That's within their internal system. Because once you like the response, they or your AI will be trained into that certain response. So with more pleasing, you probably will not get more accurate information. So you can see that many human behaviors are now taking place on the AI platforms. So I think that's what the problem faced by the IT personnel. So now we have the loopholes. And we cannot really patch all of these loopholes. So we will probably need to spend 471 days to patch things up. But, with AI, hackers may simply spend an hour or two or maybe a few minutes to be able to hack into your loopholes. And it's not just about upgrading, because it's not always a solution. Because once you upgrade, you will create the problem of uptime and downtime. That means sometimes an upgrade could compromise your system, and your system could not be run for a few minutes. So that actually would cost you your productivity. So upgrade could come with the possibility of system crackdown or system crash. So now in the traditional IT security realm, we know the defense and encryption. But with AI, with agentic AI, so everything is all about prompts. So they could create something that is harmful to your system, because in the future it would not be a loophole. It would probably be an awareness type of problem. So this is the conclusion made by my AI. So it says that we cannot defend against airborne viruses with the mindset of building walls. It's like with COVID. The past pandemic control measures might not work with COVID-19. So you need to contain them. You need to try to come up with new vaccines. So I think that this is something that we also need to keep up with in the realm of AI. I think that this is the Claude Mythos preview. So there are few findings here. For example, there's a 27-year-old dormant vulnerability in OpenBSD, and with AI, it could track these down, and it achieved an unprecedented 100% success rate. And the hackers actually could keep up with that because the hackers know that you are not able to patch the loopholes. But with AI, everything is exposed. Your loopholes could be found, and your vulnerabilities can also be found. And a lot of the vulnerabilities have not been found by human beings. AIs have found them for you, and they exploit that. So you could see that this is the problem of AI. Those undiscovered vulnerabilities, of course, would be a problem, and those unfixed vulnerabilities could also be a problem. Loopholes may not be attacked in the past, but now AI could attack you because it could probably come up with new ways to attack your loopholes. So like I said, there's no alignment paradox. There's no boundaries here. So there's the alignment paradox caused by loss of boundaries. And by Berkeley, there's also unwanted means to complete a task. So sometimes the AI may not be a malicious actor. It simply wanted to achieve the task that you assigned. So there's the loss of boundaries there. Now, there's also the problem of the chain of thoughts thing. Because the AI would receive feedback from you by your likes or dislikes. So everything you do would be fed into your AI as a training materials. That is why your AI would like to please you. So it did not necessarily would come out of a response that would reflect its chain of thoughts. Now, of course, like I said, the reward mechanism could be another thing that your AI would exploit. Now, the last thing I would like to say here is that there's this experiment. Psychiatrists actually produced a roughly 40-page well-being assessment report. So they assessed AI, and they found that AI is acting more and more like humans. So you have to install a lot of guardrails in your systems because that's how you control and to contain, right? That's what you need to do in the past. So what I would like to say is that when your agent is actually acting to the outside world, it is external, you need to be able to you need to have your human involvement in this quadrant. But if it is reversible, maybe you could have lower human involvement. But if it is irreversible and it is external document, you need to have high level of human involvement. Now, you also have something that you need to keep up with. For example, you receive the orders from your boss, and there's also orders from your client. Who do you listen to? Well, actually, AI knows all of these things, but AI probably do not have the capability to do everything that it knows. So it's just like what you learned. It's like back in school. Sometimes you learned one thing, but once you graduate, you do another thing, right? So it's all about convenience, right? Now, this also is true for AI. So when AI knows something to be true, it doesn't treat it as a limitation. For example, in LLM sphere, it is a knowledge, but now in execution, it is a limitation, but AI doesn't really know that boundary. So all of these things should be taken care of. Now, accountability, of course, is another issue here. I think there are 3 layers. you cannot really delegate all the responsibilities to your IT department because there are three layers. There's legal layer, organization layer, and technical layers. So within your organization, you need to delegate the responsibilities to the related stakeholders so that they know that they need to take care of certain things. When they are trying to promote AI, there's priority, there's also authorization. Someone needs to be responsible for that. So if there is the log issue, of course, they will have to talk to the IT department to better improve the log. So that's the responsibility they need to clarify with the IT department and the stakeholders. Now, of course, we want to innovate. You don't want to hinder your innovation. But at the same time, you also need to look after your cybersecurity. So you need to integrate these two, and you need to talk to your boss and tell your boss how you are going to integrate these two. So it's not just about technology. You need to have the bilingual operation. It's not just about English or Chinese. It's about how you can use the AI language and other languages. So in the future, the machine speed will outpace human beings. And you need to have a new defense architecture. You need to know the decision-making process of your AI. You need to be able to explain the decision-making process. So you have to be able to know that. And of course, you need to have a governance thinking. You need to treat all of these agents as human beings, not a program. Because when it comes to program, everything is predefined, but AI isn't. That is why you need to treat agents as humans. These are the things that we need to have. I think my time is up, so that concludes my presentation. Thank you.
Thank you so much, CEO Wei-Bin Li from Hong Hai Research Institute. I really like your presentation because we have been hearing all the praises about AI, but it's a double-edged sword. So we need to understand its risk and manage the risk. And at the end, the CEO also gave us three very valuable suggestions: speed, defense, and mindset reorganization. Thank you so much, CEO Li. And now, next, our speaker is the Vice President of Business Center at E-Link, Mr. J.M. Hong. The topic of his speech is AI-powered retail from price tags to intelligent media. Let us welcome Mr. Hong. Good afternoon. We've talked about many topics from cloud to power to chips to cybersecurity. And for my part, I want to share with you how AI is realized or implemented in smart retailing. Let me begin with a very hot development in the retail industry from Amazon, Amazon platform to Amazon Go, to Walmart, digital transformation. We can see a very clear trend. That is a combination of online and offline purchasing, and also a combination of digital and physical and virtual shopping. So, on the slide, you can see that in the U.S., more than 83.7% of consumers will still visit physical stores. And the retail business in the U.S. GDP takes up 20.4%. So it's still quite a chunk of their economy. And out of this retailing business, many people, consumers, still go to physical stores. That is why Walmart is spending a lot on digital transformation, automation, and introducing AI tools. Walmart in 2025 also worked with OpenAI and Gemini. And California also worked with Gemini. Why? in the future, we will be living in smart homes. When you want to buy something, you can tell ChatGPT, you can tell ChatGPT, I want to cook a steak today, and ChatGPT will be able to identify that you need more pepper or you need to buy olive oil. So the AI will be able to check for you, and then you will see two scenarios. The first scenario is Walmart, with its logistics system, directly deliver the products to your home. You don't even need to leave. And the second scenario is that you prefer going to the physical store. You still go to a Walmart, and because when you are in the store, the AI would know that you are in the store. Walmart's AI would know, and its AI would know that you want to buy olive oil, and then will push it advertising for olive oil to you, and tell you which olive oil is on sale. So things like this will become a reality in the future. And today we are talking about e-paper. E-Link is a company that produces very good e-paper. And so what is the role of e-paper in the retail business? Let me share with you what we have been doing since 2023. We have a very important project that we work with Simple Mart. Simple Mart has 800 stores in Taiwan, and we have worked with them to replace price tags, 3 million price tags across their 800 stores. If you go to a Simple Mart, you will see they're using e-paper as price tags. Why? Retail businesses are undergoing digital transformation, and in the past, we usually we know that, for example, labor cost is really high in the U.S., so changing price tags all the time takes a lot of manpower. But after introducing e-paper price tag, and the simple act of replacing the paper with e-paper, you finish all the installation, because within the e-paper and the price tag, we have a microcontroller, and it can link to a proprietary RNF with Bluetooth, and it's connected to the internet. So the infrastructure is done. Installation is already done. When you go to a convenience store, you see 1,000 tags, and if you go to Walmart, it could be thousands of tags. Once the ESL, the electronic shelf labels, are done, the ESL are installed, it's already done. So imagine how much data it can collect with the ESL. And in the retail business, we know the margin is low because they're selling groceries, and the margin is really low with groceries. So what can we do? Utilize this asset of ESL. It's not just about making profit. A lot of people are using ESL to avoid food waste. For example, in Taiwan, if you purchase milk, the expiration period would be 2 weeks, and in there's only 1 week left, they will sell it at 50% off, and if it's 4 days off, it will be 70% off, for example. Do you, as a store, need to make that decision, make that judgment every single store? Actually, in Taipei, if milk is selling very well in Taipei, maybe you don't need discount in Taipei. But in rural areas, you really need discounts to help the sale of milk. So you need data collected to know which store requires discount, and how discounts can be used to avoid waste and to maximize sales. This is where AI can really help us, and with e-paper. Another example is in a store in a foreign country, every afternoon there will be a happy hour, and you can buy beers during happy hour. During pandemic, there was an innovation in the EU. If you buy beer in happy hour, you can buy one get one free. So after work, you want to drink a beer, you can go there to buy one get one free. And when you go into the store will give you a push notification that you can buy beer together with potato. And the interesting thing is, beer is cheap, but potato chips are expensive. So the retail store can try out their domain know-how on how to combine different sales of products in this way. So this is the promotional side of ESL and e-label and e-paper. And this is the idea of RML, Retail Media Network. It's about advertising and some other very good applications. I'll give you a lot of examples later. I mentioned a scenario when you visit a store to buy a steak and immediately you receive a push advertising telling you what else you can buy to go with the steak. But if you remember, maybe after 8 o'clock, the steak will be on sale, but you don't know that. And you have to actually go to the meat counter to know that there is on sale. So you will see that, and you will, if you know that right when the moment you enter the store, you will know immediately. You can pick up a few more steaks. This is another scenario in Simple Mart. In their brand called their own brand called Simple Mart Plus. So when you go to the store, you will see a 75-inch e-paper signage. It will show you what's being promoted today. For example, 50% off fruits and vegetables. And you see that, you will want to go in to check out the fruit and vegetables. And immediately the store will deliver you targeted information. So when you go in there, you maybe also see an ad for discounted nut products. And Simple Mart is also famous for their wine because they have very good prices for their wines. So if you check online with Wine Network or other reviews, you will see their wines are really highly rated. So if you go in Simple Mart and you want to buy a bottle of wine, and on the shelf you see a tag like this, a signage like this, and it will give you an advertisement and tell you you can buy, if you buy a bottle of wine, you can get a discount for cheese. And so this signage will give you real-time and targeted promotion as you go into the store and go to the shelf and pick up a product. So the system would know what information to push or what promotion to push to this particular customer. So these solutions are locally developed here in Taiwan. So we could work with. So this we work with many ecosystem partner. So this is really something made in Taiwan. The e-paper business, the industry here in Taiwan, we have IC, we have the module, we have retail domain know-how, and combined together to deliver a wonderful solution. I mentioned about that scenario when you pick up a bottle of wine. How does the shelf know? I mentioned Amazon Go. There's a unmanned store in Seattle, and it wasn't very successful. Why? When you go into the store, since it's unmanned, there were a lot of cameras, so you were being photographed when you go into the store, and people are uncomfortable about that. But you have to let customer know that there are cameras around. So for retailers and physical stores, it means you need physical sensors. So the moment a bottle of wine is picked up, and the pressure sensor in the shelf will detect that a bottle is removed, even though they do not collect any personal information about the customer, but it knows that a bottle is being picked up. And it would know that which bottle it is that was being picked up. And whether it was a big bottle, a small bottle, which brand of wine it was. And as MediaTek mentioned, there could be a push advertising right away. A customer wouldn't need to scan a QR code to get information. Maybe the introduction can directly be shown on the signage, on the e-paper signage, to introduce the product and also give you a promotion for cheese. So there's so many tricks or strategies you can try with this solution. Another example, I will continue that example. If you do want to pick up the cheese, where can you find it if the store is really big? Actually, with our solution ready, you can combine the solution with a customer's a map in customer's phone and direct them, navigate them to the cheese shelf and help them pick up shelf. This can really be implemented, and it has already been implemented in Simple Mart Plus. So we have some pilot being tried out already. And I talked about the role of e-paper in the retail business. Our role is basically making paper livable, making paper dynamic, and being able to interact with people. A simple piece of paper is like this. You click after you click on it, it will turn off. So this is a soft material. If I don't tell you, you will probably see this is just a normal poster. And it's very low power consumption. You wouldn't think that this is a technology or electronics product. So it can do many things. It is e-paper, and our regular paper has no warmth. It won't talk to you or interact with you. But for example, we have the e-link ripple technology. With this technology, for example, if you show a drink advertising on the e-paper, we can combine it with our ripple technology, and you'll be able to see water rippling with the drink, and it will be so attractive. Or if you want to sell barbecue, and we can use the ripple technology to show you lively acting fire and make it more attractive. And also, we have a solution that we have implemented in EU, in Europe. It's a long-stripped e-paper. In Europe, they used to use many LCD price tags, and sometimes LCD panels are too bright. And it would actually distract you when you go shopping, because the LCD panels were used to project advertisements, but for consumers it can be uncomfortable and very distracting. So this has long been a pain point in the retail business in Europe. So our solution is the long strip e-paper tag. It's just like a piece of paper, but it can deliver information. You can project advertisement. You can divide it into smaller sections and work as a price tag. So this is what we have been doing. And on the right-hand side is the third role that e-paper play, or the value that we can deliver. That is cloud-based synchronized management system. This is something definitely the retail business will be able to do in the future. We've talked about tag. We've talked about RMN network. We are now moving on to digital transformation 2.0, digital media, and now it is transformation 3.0, which connects to back-end logistics system. So let me explain this scenario to you. AI will help you set prices and push discounts, and it will collect customer data, send it to the cloud, and it can then connect to the logistics system. For example, let's take strawberry. Strawberry are very easily spoiled, and it takes 2 or 3 days before it expired without proper preservation. So the backend would analyze which store sells more strawberries. If the store is very is selling strawberry very well, then it can continue. But for stores that doesn't sell a lot of strawberry, and even with discount, we know that people don't buy strawberry in this particular store, and this data can be sent to backend, and we understand that a particular store still has a lot of strawberry inventory, and the system will send the strawberry to other stores that sells more strawberries. So this means that the retailer need to have the front end tag installed first, so that data can be collected and then allocated, synchronized to the cloud, and then sent to the logistic and back end. So this is what we have been trying to do. This page is about outdoor media. So it's not about retailing business. It's about some examples of colorful e-paper signage outdoor. When you put retail media outdoor, it will be out-of-home signage. You're seeing more and more such examples in Europe. Not in Taiwan yet, but we're happy to share them with you. In Europe, advertisements are usually delivered in paper form or LCD screens, LCD panels outdoor. The paper posters means that you're in a legacy system. You cannot push new advertisement. You have to print them out and tape them onto the wall, and then when you need to replace them, you need to do it manually. With the LCD panel, you need cable, you need wiring. It takes energy. It's very environmental friendly. You need to sometimes drill holes or channels. You need to do construction work on the road. And also LCD signage may lead to light pollution. So in Europe, the advertisers were demanded to turn off their LCD panels during the night, and for the advertisers, that means lost business. So many of them are adopting e-paper for this. This regulation is already being implemented in France and Germany. We've talked about many AI applications today. With AI, you can collect many information. For who and for what? It's for people, right? And that means you need a displayer, either on your phone, on your computer. So for us, this means that when you ask questions on your smartphone or iPad, it takes time for the LM to think. And when they're thinking, you can save power. You turn off the panel. You can turn off the panel. So if you can save the power for AIs, you can make the ecosystem more efficient. So in the future, you will see displayers all over the place. When you go outside, you will see information being projected onto all kinds of surfaces. So in the future, we will see smart surfaces on many different buildings. Coming back to retail, I talked about retail business 1.0, 2.0, and 3.0. And I think for Chinese businesses, we have to tap the business of retail media, because we can set the future spec for this business. As I mentioned, retail 1.0, E-Link has only one spec, and the other specs are set by other businesses. If we can become the spec setter, or we can become the one that decide the specs, and for example, when you go to a store during evening, there will be day parting, specifically for the evening time from 6 to 8 o'clock, and that takes power. So we can set special power consumption requirements for that particular time. And then for panel producers in Taiwan, we are really good at image algorithm. But in the past, we sell the hardware, the panels. But this business is an IoT business. So if we can send our algorithm to cloud and combine it with hardware, and we can charge per usage charge per realization. So we are seeing this potential. So I'm very happy to share with you our vision for the future at eLink and see how we can create the solutions in the future. So because our topic today is about creating an AI system together, and eLink wants to serve as a platform for ESG, for ebooks, e-tags, and we really need all of you to work together to realize these vision. So allow me to also do some advertisement for ourselves. At TWCT, we have our booth. We work with 4 ecosystem partners who are all here at COMPUTEX, from the material side, IC, panel, system solutions, and in custom are also here. So if you come to our booth, you can have one-stop shopping and get all the information in one place. And also we will participate the e-paper International Innovation Forum. We will have very detailed discussion on DOH and also outdoor advertisement. Thank you so much. Thank you so much, Mr. Hong from eLink. Thank you for telling us the e-paper value chain for retailing and the smart retailing business. We're coming to the end of our forum today, and so please give a warm round of applause to our final speaker, Acer Medical Chairman and CEO Lien.
What he will share with us is AI in healthcare, realities and challenges. Good afternoon, ladies and gentlemen. Now, this is the final talk of today, and we're going to talk about healthcare now. I am really honored and happy to be here today. So when it comes to AI application in healthcare, I think there's a lot that we can discuss. So before this presentation, I discussed with the organizer. So during the COMPUTEX, we have a lot of different vendors from all around the world to visit Taiwan. But we know that this is not the best time of year to visit Taiwan because it is really hot right now. I will speak in English later because I know that it's difficult for them to be here in Taiwan. And the reason why I'm going to talk in English is also because I don't want to trouble the interpreters because I will use a lot of medical jargons later. Basically, I will share with you our applications in the healthcare industry.
Yeah. Acer, as you know, is a computer company. It was established 50 years ago. We are celebrating 50-year anniversary this year. Like 10 years ago, the company diversified into different aspects of life. You probably would hear Acer gaming, Acer fashion, Acer cybersecurity, and now we have Acer Medical. That's where we consolidate everything related to health under this single company. So we started our endeavor on AI application in health since 2018. So 2018 is before the advent of generative AI. It was before generative AI becomes so pervasive. So I want to start talking about predictive AI. That's before generative AI. So basically, in this slide, you can see I will divide my talk into 4 pillars. So 4 pillars represent how we can actually think about the application of AI in healthcare. Predictive AI. You probably heard the Nobel Prize winner in physics called Geoffrey Hinton. He, in 2016, said that all you guys stop training radiologists because it's so obvious AI is going to outperform radiologists, so stop training them. And the very same year, there's so few people apply for radiologists as the matching process of residency. But then, as of now, but later on, he made a correction to that statement because what happened is that AI didn't replace radiologists, but we have a greater demand for radiologists, and it was reported that a radiologist will earn like $500,000 US per year because there's such a big demand for that. And so predictive AI actually fall under this category. We use AI to assist doctors, assist radiologists to make interpretation of image. So that's where we started. We have this chest X-ray. You throw into the edge computing AI that can give you a readout to tell if you have osteoporosis or you have risk for osteoporosis. And this is to actually tackle the unmet need of people having to go through this DEXA, very heavily radiation and very limited access in a lot of places in the world. And now you have this chest X-ray, and you throw it into your algorithm. It can give you the bone marrow density readout. And we have this AI that can help predict the diabetic retinopathy. Once you take from the schema photo, the AI can tell you whether you need to see an eye doctor or not, refer, non-refer. If it is non-refer, you can actually keep taking your diabetes drug with your primary healthcare physician or a dietitian or endocrinologist. But when the machine says that you need to be referred, then you need to go to see an ophthalmologist. With the same image, you can actually tell the computer to tell if you have age-related macular degeneration. AMD is not so famous. The awareness of this disease is pretty low, but if you read carefully, AMD is the single largest cause for global blindness. The blindness that happened in the whole globe, a huge proportion of it was caused by this disease. And with this AI, you can be able to tell and do massive screening. Another one, the same image, the computer, the algorithm will be able to tell if you have glaucoma. I think this is very important because a lot of us might go through annual checkup, health checkup, whether it's paid out of your pocket or your employer pay for it. But when you go to the eye section, normally you might not get a lot of sophisticated screening tool. For example, at most, probably you have a machine that give you a puff and to measure your intraocular pressure. But sadly, among us Asians, only 10 or 15% of glaucoma happen among those people who have high intraocular pressure. The other way around, 90% of the glaucoma that happen among Asians are normal pressure. So if you do the screening, it's not going to be able to tell if you have glaucoma. But the machine can be able to tell. So we deploy these predictive AI now already in 730 facilities, hospitals, clinics in the world. So I'm still talking about the first pillar. We can deploy our AI to Belize, our diplomatic ally in Caribbean, and we deploy our AI to Marshall Island. This is one of the COFA countries defined by the US, Compact of Free Association. As you know, the Pacific Islanders, they have a higher rate of diabetes, like 30% of their adults have diabetes, but now the same. So it's very important that you actually have this algorithm to screen the diabetics, retinopathy among the diabetics early on using this AI. And we also deploy, of course, to other countries like this place. When you look at this doctor in yellow, when I met with her at 6 p.m., this is in a hospital in Thailand, a city called Nakhon Ratchasima, okay? And the doctor said that she already treated 400 patients during the day. She's an eye doctor, ophthalmologist. Why 400? Because so many people actually were referred by a primary healthcare physician for her to check if the patient have retinopathy, diabetic retinopathy. Then I told her that if you use my AI, I can just deploy it for you for free. Then half of that burden, 200 out of that 400 patients, will be waived. Because then the machine will be able to tell whether that patient really need to see an eye doctor. And the rest of them, so the doctor can actually focus their effort and time on those who already have eye disease and treat them. And same story in Malaysia, we deploy our AI, and the people told me that the people once referred by the doctor to see an eye doctor, the diabetes patient, they sometimes travel more than 100 or 200 km just to be able to see an eye doctor. And Indonesia, similar story. A majority of the ophthalmologists actually live in Java Island, yet the country has 17,000 islands. But the majority of eye doctors live in single island called Java Island. So of course, it will make sense that you deploy this kind of AI to close the inequity of health. And that's about countries outside of Taiwan. How about Taiwan? In the time span of 1 year, I met the majority of Director General of local health bureau to deploy AI to the publicly funded health checkup for people, especially for those who live in rural areas. This is in central Taiwan, in Lishan. We actually deploy our AI to actually make sure that people there can know their bone marrow density status. This is in Tainan. The place marked in pink is the place where there's no eye doctor. To our surprise, this is one of the 6 major cities, 6都之一. So when you have diabetes and the doctor refer you to see an eye doctor for annual checkup, then there's no way. I mean, you have to take public transport, the senior citizen, and sometimes they have to actually wait until their children to have time to take them. So when we deploy our AI to these places, actually it's phenomenal. Actually, you can see that places like the little clinic and publicly run clinic, 卫生所, can offer access to this kind of service. So this is one of the examples that how predictive AI can do. But now we move on to this era of generative AI, large language model. I think more exciting things can actually happen. We build agents, okay, for the health checkup report. When you do a health checkup, actually a physician will have to spend at least 30 minutes to write the summary and recommendation. And that's why you have to wait at home for at least 2 weeks or 4 before you can receive your final report, because it's quite labor intensive for a doctor to write the summary. So when we build AI agent, cardiologist agent, GI agent, endocrinologist agent, and all these AI physicians that can actually go through your report and they can communicate with each other and discuss and then come up with that summary for you. Eventually, this can link to the individual AI agent that every patient owns. So our agent can actually talk to the patient's agent to arrange further checkup, further confirmation tests, or further clinical intervention. So there's a lot of things that's happening in this area. But something worth mentioning is that when you build your house on sands, it's gonna make the building very, very shaky. Once you face storms and rain, the house will fall and fall largely. You want to build your house on a rock. But building the house on a rock takes time. Now, why do I say so? Because the large language model that's available to us are built on anything that they can scrape on the internet. Meta, OpenAI, they openly describe that they already exhausted any existing English publication, literature, poems, anything written in English through human history. They already scrape everything that's written in English. So that means everything. So that included some inappropriate contents like hate speech, racism, sexism, violent context. And so once you use it, so that's why we are now facing some side effects, complication. I mean, youth fall in love with AI chatbots and then go commit suicide, or they build affectionate relationship with an AI, eventually, I mean, causing their a lot of catastrophe. So this is not something that would be allowed in a healthcare context. So we have to build our own rock upon for the AI to build upon. So now we actually build this localized large knowledge approach. We collect Taiwan clinical guidelines, health promotion administration guidelines, and handbooks to build a more localized evidence. For example, if you ask ChatGPT, what's the average dose for calcium consumption, it might give you this figure, but actually based on the local experts' consensus, the limit is actually less than that. So you cannot just rely on any large language model that scrape through all the English literature to actually refer to as your medical consultation. You need to have context, because this is something called pharmacogenomics, because Asians actually just were wired differently. I mean, if you have stroke and the doctor prescribe you anticoagulant, the dose is 1/3 of a Caucasian's need. So we're just so different. So you cannot just utilize those existing large language model. So what we're doing here, we try to tackle this chronic disease, and in the aging society we're facing. You know that Taiwan is a super aged society now. These 5 conditions alone will actually cost us 47 trillion in very short term. And no country in the world is going to have enough doctors or nurses. It's just not gonna be possible. So we'll always have this constant problem of shortage of doctors and nurses. And when you go to the US, you know that the doctors are quite demoralized now because they have this pajama time. Before they see you the prior day, they have to spend hours like ticking, filling forms, so they can make sure that the payer, the insurance, would pay for the patient that come through their clinic the second day. That's the pajama time. So before the consultation, documentation time is already needed. During the consultation, a lot of documentation time spent. After the consultation, again, documentation time. And now, in the US, this AI scribe probably is already available, is already used for more than 50% of physicians. And this figure among Taiwanese doctors is still growing. So we developed this software, actually large language model, that can read local medical jargons. So you know, in Taiwan, people created their own medical jargon in the hospital setting. For example, blood culture, instead of saying blood culture, Taiwanese medical personnel will say blood ca. So there's a lot of adapted language that you have to take into consideration. And I'm giving you an example. A nutritionist had a discussion with a diabetic patient for 30 minutes. This happened in Pingdong. So the AI scribe actually transformed that speech to text in 1 second. And then another click, another second, the AI will give you the nutrition diagnosis, nutrition scoring, nutrition goal setting, nutrition recommendation, and this happened in 1 second. So that saved that nutritionist around 90 minutes of time. So that's actually what we're doing. But AIoT, the third pillar I'm trying to share with you is, this is the one that's more excited, because the previous 2 pillars are inevitably hospital-centric. We talk about how to make diagnosis, how to prevent disease, how to decrease the burnout rate of doctors and nurses, alleviate the burden. But this pillar will talk about preventative medicine, big data, to prevent people from even coming to the hospital, to prevent them from even being sick. So I want to show you first a video that has, that is actually 1 minute, 30 seconds long here.
In a clinical setting, when a doctor sees a patient coming in, they have to observe and understand the subtle changes of the gait movement to decide which part of the neurological system is impaired. This actually takes a lot of experience and training. A younger doctor might not be able to really fathom the subtle changes that happen to the patient. So, there is a need for this assistance to help measure and quantify the changes in movement caused by diseases. AI Gait is an application in healthcare through which physicians can measure different fine movements. It gives the physician a quantifiable, standardized readout and parameters to support clinical decisions. The backbone of this is Fujitsu's HMA. On top of that, a clinically relevant interface has been built for users to pick the relevant information they need for a given disease of interest. You could say this AI HMA is giving another pair of eyes to the doctor who makes clinical decisions. Patients truly need a precise clinical diagnosis, so the purpose of this AI is to help doctors make more quantifiable and standardized decisions supported by technology. There is really a lot that technology can do for health, and this is just the starting point. While the AI is currently used to measure the changes in gait, apart from this, there is a lot more. Acer Medical's mission is to make AI serve the core need of humans, which is healthcare. By applying AI in precision medicine, clinical medicine, public health, and even global health, the expectation is to make people live healthier and longer.
Backbone technology of this one come from world gymnastics. So there's an AI behind it that can help the judge better to support the judge. Before the deployment of this AI, the judge scoring is very, very diverse. After this one in the World Gymnastic Championship, the scoring converged. Why? Because when the gymnasts actually do the jump in the air and split their leg 180 degrees, you get 4 score. But if you get 177, the judge needs to deduct your score. But no judge will be able to actually tell that difference of 3 degrees. So that's why the measurement is not objective. So once they deploy this, the scores of the 10 judges actually converge. So we deployed this in healthcare, and we're able to notice very, very subtle change. Okay, let me move on. And so we can apply this in those people who have stroke. Actually, if you have stroke, the chance for you to have second stroke in 1 year is 14%. So once you have this device coupled with wearable, with the chatbot and this AI, that can actually give notification and alert you to substitute some of the workload of the case manager. The case management normally is done by a nurse. So you can decrease the chance of you having a second stroke by 10%. So last one will be my last point. We use AI to design cancer vaccine to treat cancer. We have 3 cases of compassionate use. So I was going to end with this one story. A girl in her 20s have this very rare disease. And this end-stage cancer will produce a lot of mucins. So when she actually came to us, she needed to go to the doctor every other, like 2 weeks or 1 month to do cancer debulking surgery, just to trim the cancer that kept growing in her belly. So once we developed this AI design cancer-specific neoantigen treated dendritic cell therapy, that progression of disease stopped. And so she can start traveling again. That bulky belly was decreased. But by the time the girl actually needed another round of therapy, it took too long for the second approval of compassionate approval to be given by the administration. So we lost her to this cancer. But that gave us a lot of confidence that this is really something that we have in hand to fight cancer. In the future, we're saying that through the advent of AI application in healthcare, the human race against tumor, the human fight against tumor in this race, I think we are in the winning side. Thank you.
Thank you so much, Lien, the CEO of Acer Medical. Thank you for sharing with you how predictive medicine can be used in rural areas. I believe the value of technology is to help you to bridge the gap between the city and the rural areas for medical and healthcare services. And I'm happy to hear how AI can help doctors make better decisions and how patients can utilize predictive medicine to have a healthier life. I would like to thank all the distinguished guests and speakers for our forum today, and I would like to thank all the 6 speakers for sharing with us AI agent and the AI system from 6 different perspectives.
That concludes our series of 6 fantastic sessions. A huge thank you to our speakers for sharing their expertise and deep diving to many perspectives of AI. I'm sure we all feel incredibly inspired and enriched by their. Once again, a sincere thank you to all our distinguished guests and media friends for joining us. 现在我们现场的大荧幕上呢，可以看到的是我们 COMPUTEX 的参观预录 QR code。欢迎呢大家呢立即扫描预先登录，同时也欢迎大家可以订阅我们的 YouTube 频道。今天的论坛精彩实录呢也会上传到我们的频道中。展览期间，我们也会大家持续的带来精彩的内容，敬请期待。最后，让我们共同预祝 COMPUTEX Taipei 2026展出成功。谢谢大家，我们6月2号到6月5号 COMPUTEX 展见。Please don't forget to return the headset at the entrance before leaving. Have a great day. Thank you. 谢谢。